Okay, hi everyone. I wanted to do a quick video that reviews the warm-ups just to make sure that we understand Punnett squares. So Punnett square is a square that's cut into four boxes and it determines genetic probabilities. So when two parents have a baby, they have alleles. So these two parents both have brown eyes. They're heterozygous dominant, which means they have two different alleles. They have a capital B and they have a lowercase b. So when they go to make a child, the way that those alleles combine could be four different ways. I want you to think about a Punnett square as the total possibility is 100%, right? So when we look at the possibilities or the probabilities, pretend like 100% is a dollar. So look at this dollar right here. If we cut a dollar in four, we have quarters, right? So 1/4 is 25 cents, 2/4 is 50 cents, 3/4 is what? 3/4 is 75 cents, and then 4/4 would be a dollar, okay? 100%. So when we look at the way those alleles combine, we can see that we have 3/4 or three children that have brown eyes. That's their phenotype, right? How many have blue eyes? One. One out of how many? One out of four. So if it's one out of four, one out of four, one out of four is really just talking about 1/4. See that? How much is a quarter worth? 25 cents, right? So we say that 1/4 is a 25% chance that the child would have blue eyes. Make sense? Okay, let me go to the next slide. Okay, so here's an example. It says in dogs, there's a hereditary type of deafness caused by a recessive gene. Two dogs who carry the gene for deafness have normal hearing, but they're mated. What's the possible genotypes and phenotypes of their offspring and percent chance for each? So when you go to combine their alleles, all right, we have two heterozygous parents, right? They have this allele that's recessive for being deaf. When they have a baby, is there a chance that their baby could be deaf, even though they are both hearing? So let's go ahead. I'm going to show you how to combine these alleles. So you have a capital D. So you're just going to put that together. That means homozygous dominant, homo, same. Then you put the D, capital D and lowercase d together. That's heterozygous dominant for hearing. Okay, you're going to find the same thing in this square down here, capital D, lowercase d. But in the last square, when you combine the two lowercase d's, we see that there's a possibility, a probability that you can have a deaf child. Just like you did in the last example, you had a blue-eyed child, right? So when we look at the genotypes, there's three different genotypes. Your genotypes are your genes. So I came up with homozygous dominant, which is capital D, capital D. That means that the phenotype is that they will be able to hear, hearing. Okay. Now, if you have a capital D and a lowercase d, that's still dominant for being able to hear. Okay. Now let's go ahead and take a look at the chances here. How many D's, I'll probably do this in a different color. How many genotypes are capital D, capital D? You have one, right? So you're going to have one out of, I don't like this color. One out of how many boxes are there? One out of four. Do you remember the percent chance that is? That's 1/4. So that's going to be 25%. So you can either write this as 25%, or you can write it as 1/4. Okay. How many of the children could be heterozygous? Capital D, lowercase d. How many do you see? I see 2 out of 4. Okay, so 2 out of 4 in this case, I'll circle them, okay? 2 out of 4, I'll circle it in pink. 2 out of 4 is the same as 2/4. How much is 2/4 worth? 50%. Okay, half of the kids are going to be able to possibly hear. So I'm going to say 50% is the same as 2 over 4. Okay, fractions, quarters. Awesome. Now, the last genotype that we're talking about is going to be the case where you have 2 recessive alleles. So 2 recessive alleles means, the dog is going to be deaf. Now, what's the chance that these 2 hearing parents are going to make a deaf child? Well, looks like it's another 1 out of 4, right? 1 out of 4. Do you remember how much 1 out of 4 is? How much is the quarter worth? The quarter is worth 25 cents. We can convert cents into percentages. Okay? Does that make sense? Okay. All right, let's go to the next one. I want to talk about another situation. Okay. Now it's asking what's the probability that a brown-eyed and a blue-eyed parent are going to create a child with blue eyes. So it's basically saying a parent that has the recessive genes, homozygous recessive, and also heterozygous dominant. So let's take a look. All you're doing here is looking at the Punnett square and literally circling the blue eyes, which is the phenotype. Physically, they have blue eyes. How many of these children are going to have blue eyes? Look, I see 2 of them. 2 of them, that means 2/4. How much is 2/4 worth? Let's see. 2 out of 4 is what percent? Tell me now. That's half of them, right? Half. It's really kind of the same as saying 1/2. I just want you to see that these are equivalent fractions. You know what I mean? Because it's like half the kids. But what percent is that? 2/4 is 50%. With me now? Or 50 cents, right? Okay. Love it. So let's look at one more scenario here where we're going to create some Punnett squares. This is talking about guinea pigs. You have guinea pigs. Now, short hair is actually dominant. When you have a long-haired guinea pig, that's a recessive trait, right? So dominant is capital, recessive is lowercase. Dominant is what? Capital, and recessive is lowercase. So let's go ahead and put these together here. So we're going to combine, we're going to combine these alleles. We're doing a genetic cross. So we're going to combine capital S, lowercase s. So capital S, lowercase s. Same here, right? Capital S, lowercase s. And look at this. I think it's almost the same each time. Capital S, lowercase s. And again, capital S, lowercase s. Well, won't you look at that? Let me ask you a question. Do they all have the same genotype? Capital S, lowercase s. Are they all the same? How many of those squares do you see with the same genotype, capital S, lowercase s? Let's see. 1, 2, 3, 4. Let me ask you a question. 4 out of 4. What's 4 divided by 4? 4 divided by 4 is 1. I'm saying 100% of these kids are going to have what? Long hair or short hair? Guinea pig. What does this genotype tell you? If you have 1 capital, that's dominant, right? What's the dominant trait again? The dominant trait is short hair. Okay, so the phenotype is saying, listen, these kids are going to have short hair. Yes. And the percent chance of that happening is what percent? you can say, well, that's a 100% chance. All of the kids are going to have short hair. And that is 4 out of 4. Love it. Okay, so hopefully this is helpful for you in filling out your Punnett squares and determining genetic probabilities. Again, probabilities are out of 100, so think about 100 like a dollar, and think about quarters. You got 25, 50, 75, or 100. All right, have a great day. Hopefully this is helpful.